orbiting Jupiter.
Beneath its icy surface, a global ocean of water. Everywhere on Earth that there's water, there's life. So we want to understand, could Europa be a place where life might exist today?
3, 2, 1, lift off.
Europa Clipper is the first mission dedicated to exploring Europa.
This is the largest interplanetary spacecraft NASA has ever built and launched.
We have the right team, the right technologies to leverage to go to Europa now and unlock those mysteries that are just waiting for us.
The pictures we're going to get from Europa Clipper are going to blow our minds.
How could you not be excited about something as monumental as this?
You're looking live at NASA's Kennedy Space Center's Launch Pad 39A. SpaceX will soon begin fueling that Falcon Heavy rocket for NASA's Europa Clipper mission, a nearly 2 billion mile, 5.5-year journey to Jupiter's icy ocean moon. Good morning and welcome to the Space Coast of Florida. I'm NASA's Megan Cruz and this is NASA Jet Propulsion Laboratory Engineer Jenny Kampmeyer. So glad to have you here today.
I'm so excited to be here. It's launch day.
Yeah, absolutely. I know. I think you're containing yourself. I feel like you're way more excited than you're portraying right now.
I am very excited.
Well, Jenny's here because she's going to help me tell you all about this mission. And right now we're currently marching towards a 12:06 p.m. Eastern launch. And Jenny, the mission name really says a lot. So we are going to sail, and that's the Clipper part, past Jupiter's moon Europa, where scientists believe there's an ocean beneath the icy surface. And why, Jenny, do NASA and its partners want to go there?
You know, at least on this planet, wherever there's water, we find life. And to know that there's a place in our solar system that not only has some water, but an abundant amount of water. Underneath that icy crust, there's this global saltwater ocean. And so we want to go there to see, is this a habitable place? Could it support life?
And why do scientists believe it could have those ingredients you're talking about?
Yeah, so we've actually been to Europa before. We have some kind of tantalizing evidence from previous missions. We've done a few flybys of the moon and gotten some data that, showed us that there's this ocean of water. And so we look, and then we kind of continue to study it and we look for those ingredients of life, the chemistry, the energy, the time, and the water. We think Europa's kind of been simmering away for about 4 billion years. So it's a really exciting place to go to look to see, is it habitable?
Right. And how many years has this team been working towards this goal?
This mission has been in the works for a long time. Folks have been trying to kind of literally get this mission off the ground for about 25 years.
Wow.
Yeah.
And what's your role within this? Really felt the impact there. We know some were without power for days, Jenny.
Absolutely. And, we both have friends and family in the area. Impacts from the storm. So I'm really
touched down just right. And a lot of other people who are here for this mission were staying.
Absolutely. Yeah. And, definitely a scary moment for the team, but everyone was okay and we made it through.
Yeah. I think it really demonstrates that both NASA and SpaceX have remarkable skill and determination to, even after all that, get us to launch day today.
Absolutely. NASA always puts the safety of the thing we care the most about is keeping our people safe. Able to keep that goal kind of at top of mind. While also making sure that we could get to today. So it's really amazing that, we prioritize the safety of our people, but that we got to this moment today of launching this mission.
Yeah. What do you have to say to the team again as we march towards the T0 today of 12:06 p.m. Eastern?
I'm just so thankful and proud of everybody. It's amazing to get to kind of represent the team, but it's really thousands of people who've worked on this project.
As we've been talking about, really looking forward. And I think what's really cool about that is just how widespread the interest is in this mission.
It's amazing. Of course, I'm a big space nerd, as a lot of us are. There are a lot of people who are space enthusiasts and have been excited about this mission, but to start to see other folks, maybe this is the first time they've been exposed to something as cool as Europa Clipper. It's really cool to see the excited about this mission.
Yeah. And I know they're watching us today, so
Yes.
that'll be really fun. And for our Spanish-speaking audience, if you're interested, NASA has a Spanish broadcast on our NASA Plus app, and this QR code you see on your screen there is going to take you right to it. NASA Plus is our free on-demand streaming service.
Off this morning as
Lauches farm is doing for us.
Yeah, being for the mission over the science window. They upgraded their Lauches farm at Launch Complex 39A, and they can now recycle and densify Lauches every 48 hours, which gives us a lot more launch availability for a mission on a Falcon Heavy. So a huge upgrade that provides great access for the missions to be able to launch on time.
And now that we're inside of Lauches load, we are not going to do a 24-hour recycle. We would be a 48-hour recycle if something happens and we scrub for some reason that's not a technical one. All right, when we come back, we will load the second stage of the rocket. For now, we'll send it back to Megan and Jenny.
All right, so everything going really well as we are 42 minutes and 40 seconds from liftoff of a SpaceX Falcon Heavy rocket with Europa Clipper. Now we have some spacecraft facts for you now, actually. Europa Clipper is the largest spacecraft NASA has ever developed for a planetary mission. It is 15.5 feet high by more than 100 feet long when you include its solar arrays. That's longer than a basketball court. It's also the heaviest spacecraft at about 12,800 pounds, and 6,000 of that is just fuel. The spacecraft has 9 science instruments plus a gravity and radio science investigation. All that will work together to study Europa's atmosphere, surface, interior, and space environment. And most of Europa Clipper's electronics are protected in a special vault. Jupiter has one of the most punishing radiation environments in our entire solar system. Now, the spacecraft was assembled at JPL in Pasadena, California. You can see it there. Shipping it here to Florida for launch, now that took a lot of coordination. First, some parts, like its high-gain antenna, were removed so it could fit in a shipping container. Then 2 semi-trucks drove the spacecraft, plus support equipment about 70 miles to March Air Reserve Base. There it was loaded into a C-17 plane for its flight to Kennedy Space Center. And then once here, it was reassembled, as you can see there, and fueled in a clean room before it was encapsulated into the rocket's payload fairing. That fairing is at the top of the Falcon Heavy rocket you see live there, and it keeps the spacecraft safe through launch. And once Europa Clipper is delivered to space, it will take 5.5 years to get to Jupiter and Europa. Jenny, why so long?
You know, it's a good question. We actually get this question all the time. Like 5.5 years, that's so long. Really, that's because space is really big and Jupiter is really far away. So even with getting this huge boost from the Falcon Heavy rocket, and we also do 2 gravity assists around Mars and actually around the Earth as well, that gives us a little extra kick of speed. Even doing both of those things, it still takes 5.5 years to get there.
Yeah, I think that's good to keep in mind. Talk a little bit about the gravity assist. How does that work?
Yeah, so a gravity assist is basically basically when we fly the spacecraft really close to another body like Mars or the Earth or Venus, when we do that, we actually steal a tiny bit of energy from that body, and the spacecraft takes that energy to pick up a little bit of speed. Of course, those planets will never notice that they had a little bit of energy stolen from them, but that's how we get that extra speed.
Okay, yeah, I'm really glad you talked about that. I think that's really interesting to really explain that energy stealing part. I think that's really cool. And when the spacecraft arrives at its destination, take a look at this video. So that yellow dot in the center, that's Jupiter, and then the white circle is Europa's orbit. The pink line is the spacecraft's trajectory, and this is showing how Europa Clipper will observe Europa.
Absolutely. So yeah, you can see these the pink orbits kind of building up over time as we orbit Jupiter and do successive flybys of Europa. We have this mission designed because of the really intense radiation environment. We don't want to bathe in that radiation all the time. So that's why we kind of do a quick flyby and then get out to be able to downlink all of our science data and do other engineering activities when we're outside of that radiation environment.
Yeah, I want to point out again how much science and skill goes into designing a trajectory like this so that we protect the spacecraft when it gets there.
Absolutely, and it doesn't happen by accident. We have to continually fire our thrusters to be able to maintain this trajectory.
Yeah, it's also very pretty.
It is.
All right, we're now 39 minutes to launch here at Kennedy Space Center in Florida. Let's head back over to Tony.
Thanks, Megan. Joining me is Dr. Gina DiBraccio, the Acting Director for the Planetary Science Division within NASA Science Mission Directorate. Gina, how are you feeling today?
You know, Tony, I'm just so excited to be here and see all of the amazing hullabaloo that's going on for this launch today.
Me too. I'm very excited indeed. You know, as we get ready to study the liquid water beneath Europa's icy crust, what are the next steps for the space agency?
Yeah, so, you know, first we're getting so much data that our scientists are just going to be unraveling the discoveries at Europa. So it's really premature to say what's next for Europa, but as far as planetary science is concerned, we have a lot of exciting missions that are coming down the pike. We have the Dragonfly mission, and we'll be exploring Titan and the chemistry on that moon of Saturn with a rotocraft that will actually be landing and then flying to other locations. And then we have Venus missions coming up. We have Veritas and Da Vinci that will be looking at the geological history of Venus and also the atmosphere as well. So it's a great time for planetary science.
Absolutely. I cannot wait for all of these future missions. You just mentioned a few that sound very exciting. Why is it important, you know, to study ocean worlds just in general, like Europa, though?
Yeah, so as far as ocean worlds, you know, we believe that they are the most common type of planetary body throughout our universe. And within our own solar system, we have the ability not only to study Earth, but to go to Europa, to really look for that water and to understand how water is one of the key ingredients to life. So with Europa Clipper, we're not searching for life on Europa, but we're trying to see if this ocean world is habitable. And that means we're looking for the water. We're trying to constrain the ocean underneath that icy surface. We're looking for energy sources, and we're really looking for the chemistry there so that we can understand what habitable environments might be throughout our whole universe.
That is very exciting indeed. I cannot wait to discover what we find out. Gina, thank you so much for joining us. Sending it back over to you, Megan.
And people from all over the world watching today's launch. So we invited you guys to send us your questions if you have any. So why don't we start taking some of those now?
Absolutely. Let's do it.
All righty. So the first one is from Instagram. This is, will the satellites that will be sent to Europa need to return back to Earth for the data?
Well, it's good that we don't, because otherwise we'd have that long 5.5-year journey all the way back to Earth to get the data back. So we actually have a really big antenna on the spacecraft called our high gain antenna. If you've seen the photos of the spacecraft, it's the big silver disc in the middle. That's our antenna, and that's what's going to return all of the data back to Earth. That's my favorite part of the spacecraft because of that, because that's how we get all that amazing science data back.
But we don't get it back immediately, right? I mean, it does still take a long time because of the distance.
Exactly. So it takes light about 45 minutes to travel from Jupiter back down to the Earth. So if we say hello to the spacecraft, it takes 45 minutes for that hello to get there, and then another 45 minutes for their hello to come back. So it does take a little bit of time.
But still, 45 minutes versus 5.5 years. Like,
yes.
That's very impressive.
Exactly.
All right, let's take another question. This is also on Instagram. What are some of the technologies on board to help with new discoveries?
Yeah, so if you stick around later in the broadcast, we're going to talk about all of the instrumentation that's on board and go into that in detail. But we have a really advanced suite of instruments that are going to help us answer all these questions about Europa. So we have mass spectrometers, we have a really advanced camera that's going to take amazing photos to help us learn about the geology. We have dust detectors and magnetometers. So we have all sorts of scientific instruments to help answer those questions.
Awesome. Thank you so much. All right, let's check back in on propellant loading with Daryl and Mick.
And we are moving smoothly through the countdown so far, Mick. No major issues worked. Tim Dunn, the NASA launch manager, mentioned some minor things. You want to review those?
Yeah, those were just minor preps that the team was working prior to getting into prop load, and the team dispositioned those and worked those and acknowledged the things in the procedures. So pretty common, but getting prop load going.
Now we're listening for stage 2 to begin its RP1 load. And we can see on our displays, which have an interface that shows us and confirms that indeed stage 2 has begun RP1 prop load. Again, stage 2 has begun that prop load. This is an autonomous process, so we won't always hear a call out.
Yeah, correct. The SpaceX team has software that controls their fueling and gets things going. As we see RP1 on the 3 boosters, locks on the 3 boosters, and now we're starting to put RP1 in the second stage RP1 tank, and things are progressing very well towards launch at 12:06.
And Mick, this is just the 11th launch of a Falcon Heavy, so this is a special occasion. SpaceX launches a lot of rockets. They're approaching something like 400 launches. So this 11th of a Falcon Heavy is really key. They also did some special work on this launch for this spacecraft by putting something together for its necessary cooling. The Europa Clipper spacecraft has some very tight requirements when it comes to cooling and to purity of the air in there. It has to have high-grade nitrogen flowed in there, and they built something called an octonozzle, which is literally, I'm going to make it with my hands, 3 nozzles that are pushing air onto the radiators of the spacecraft.
Yeah, the team has to meet planetary protection requirements. As you mentioned, Europa Clipper has some strict requirements for the environmental control system within the fairing. And so this is just one of those things that SpaceX came up with to be able to get the ECS and GN2 flowing in the fairing around Europa Clipper to maintain all those requirements. Ingenious thing that they've done to make sure they can keep Europa Clipper within limits.
Europa Clipper sitting at the top of this Falcon Heavy rocket, and indeed, the spacecraft team has also been getting and configuring this spacecraft to get it ready for launch.
Yeah, team's been working great. We've been listening to the spacecraft team configure Europa Clipper, getting things ready to go. Later in the count, we'll hear them go on internal power. So continuing to follow their procedures and work all they need to do to make sure Europa is ready for launch at 12:06 p.m. today.
All right, and we're waiting that T0 at T-minus 32 minutes and counting. We'll send it back to Megan and Jenny.
Great news that fueling continues to go well on the rocket. As for the spacecraft, let's get back to Raquel for another check.
Megan, Mission Control has been conducting readiness polls, team-wide check-ins before launch to confirm everything is good to go. The activity lead is making sure the launch-specific software is ready to run, and after liftoff, she'll be monitoring it to ensure everything on board is working as expected. While Mission Control takes care of those final details, let's take a closer look at why Europa is the focus of this mission. Earlier, I spoke with Europa Clipper Deputy Project Scientist Bonnie Barati, who gives us a glimpse of what's beneath the moon's icy crust. Bonnie, we are here with a model of Europa that shows us the layers that we can see underneath its crust. First off, before we get to it, can you tell us about the characteristics of the moon?
Europa is one of the large icy moons of Jupiter. There are 4. They were discovered by Galileo in 1610. And it's a little bit smaller than our own moon, but unlike our moon, it has a lot of water, about twice as much as the Earth does. If you were approaching Europa from afar, you would know immediately it's really an odd object, unlike any other in the solar system. Let's just start with the surface.
I see all these ridges and crusts and grooves. Like, what is it about this geology that makes it different?
Well, there are hardly any craters on this unusual surface. We see a lot of evidence for cracking and active geology, so we think it's either active now or was active in the recent past.
Once we get past this surface, we see this layer of ice. Can you tell me more about this ice and how much of the moon it covers?
Well, it covers the entire body, and the ocean is global. But the crust it's about 15 miles or so, perhaps more or less, but it definitely blocks any sunlight from this water underneath this global ocean.
What other key ingredients are there for life that might be on Europa?
The other two necessities for life are chemicals, some type of food for any organisms, and also a source of energy. We can't use the sun because we're underneath that ice crust.
And you think that energy is coming from that rocky third layer below?
Yes, there is a rocky mantle to Europa, and it is in contact with this ocean. And we believe there are some unusual features down here that are caused by Jupiter. Jupiter is huge. You can fit 1,000 Earths inside of it. And on top of that, the orbit of Europa is not quite circular. So when it gets close to Jupiter, it gets kind of squashed. And then when it gets further away, it releases this mechanical energy into thermal energy. And we believe this comes out as thermal vents at this interface between the rocky mantle and this ocean. And not only do these thermal vents release energy and additional chemicals, but they provide the ideal region for a habitable environment, which is the main goal of our mission. We're looking for an environment that could support life.
And there is so much left to learn about Europa. Bonnie, I want to know what you are most excited about.
I'm most excited about the unknown. Every mission that has gone to an object we haven't studied in detail, we've discovered something that we couldn't envision, something so wonderful we couldn't imagine it. That's what I'm looking most forward to.
Great. Thank you so much, Bonnie.
Thank you so much, Raquel.
Now, you just heard in that video that Europa and our moon are roughly the same size, but they could not be more different when it comes to water. Europa is believed to have twice as much water as Earth, while our moon has a fraction of that. NASA wants to learn how to use our moon's water to live and work there. The Europa Clipper mission will explore whether there's an ocean beneath Europa's icy crust. If it finds one, along with energy and organic molecules, then there would be the right ingredients for life. NASA has long been on a quest to find life beyond Earth to better understand how we came to be. NASA is also focusing on the water on our own moon in preparation for future Artemis missions. Artemis will mark the first time astronauts return to the lunar surface in over 50 years to eventually send people to Mars. Water plays a key role in this plan. If NASA can figure out how to harvest and use the moon's water, astronauts could drink it, turn it into breathable air, or even use it for rocket fuel. Scientists think the moon's poles might have tons of ice, while the sunlit areas a lot less water, 100 times less Sahara Desert. Artemis 2 will be NASA's first crewed mission under the campaign and will pave the way for the first.
Alvin, thank you both so much for being with us here today. Jim, can you tell us a little bit more about why the Europa Clipper mission
about Earth itself and just how this advances the field of astrobiology as well. So it really does go to our innovating in air and space at NASA.
Absolutely. And Kate, Hurricane Milton delayed the launch of Europa Clipper, and already this year there have been 13 named storms, with another hitting Florida only a few weeks ago. As we get ready to send the spacecraft to study its ocean world, its climate and environment, can you reflect on our own climate and the increase in storm activity?
Yeah, so Hurricane Milton and Hurricane Helene before it had devastating impacts across Florida and throughout the Southeast. And our focus right now is making sure that we can get information to first responders so they can help with recovery efforts. At the same time, scientists are studying hurricanes so that we can better understand how they form, how they've changed over time, and use that information to better predict future storms and plan for the future. And what we know is that climate change is leading to a higher proportion of strong hurricanes. So of the hurricanes that form, more of them are categories 3 through 5. And we're also seeing more heavy precipitation events, so more heavy rainfall associated with hurricanes, which can have really severe flooding effects. And so we're focused now and helping first responders, but also thinking about how we can better plan and prepare for the future.
Absolutely. Jim, going back to Europa, is Europa one day, a target or a goal, a destination that NASA is perhaps one day interested in sending astronauts to?
It's not a very kind place for human beings with the radiation environment that it has. So what it does set up for is our robotic explorers, which we have done throughout the entire solar system, and now with Voyagers even going beyond that. But while Europa Clipper is exploring Europa, we'll have crews at the moon, further understanding the formation of the moon and how the formation of the solar system as well. So it's a complementary effort that goes to our whys at NASA, which is science, national posture, and inspiration. So we'll be doing that with both the Artemis and the Europa missions.
Thank you guys both so much for joining us. Megan, back over to you.
Now, the Europa Clipper mission has captured the attentions of people all over the world, even a beloved coach from the show, Ted Lasso.
Hey everyone, I'm Brendan Hunt, and I'm not a real coach, but this is a real beard. Today you have teams of people gathered for the launch of NASA's next big adventure, the Europa Clipper mission. I can only imagine how much teamwork it took to get here. Collaboration and trust between scientists, engineers, and experts from various fields working together to ensure every aspect of the mission is meticulously planned and executed. Everyone involved has to believe in each other and in their collective capabilities to drive the project forward. There must be a sense of curiosity in order to push the boundaries of exploration, pushing people to ask new questions and seek answers to the unknown. And there must be kindness, a willingness to respect each other's contributions in a supportive environment where innovation thrives. Thank you so much to everyone involved in NASA's Europa Clipper mission. This historical project is an inspiration to the country and the world. Teamwork, belief, curiosity, kindness. They can take us a long way. All the way to the moons of Jupiter, which are out there, I bet. Europa Clipper, baby!
Okay, I love that. I love the Europa Clipper baby at
So
the
great.
end. But also, yes, while funny, I mean, he really touched a lot on, the things that matter to this team: teamwork, belief, curiosity, all those things.
Absolutely. He really gets it, that this mission is spacecraft hardware, but it's really the people, right? There's so many people involved in building this thing, and yeah, it's amazing.
Specifically when he said kindness, you reacted to that. What about that particular word really spoke to you out of that story?
Yeah, I think it just really speaks to the humanity. We are all humans. We're trying to do good things here, and when we're kind to each other, it really makes a difference. So him kind of acknowledging how important that is for our team to work well together, yeah, it just means a lot.
Yeah, that was a good pep talk.
Yeah.
Thanks, Coach. Thanks. All right, so we are now 22 minutes from liftoff, and we have some time now to take some more of your questions about Europa Clipper Live. So let's roll one video that we have now.
Hello, my name is Liam. I'm in the 8th grade, and I was curious to know, is there any land under the oceans of Europa?
Yeah, that's a really great question, and we do get that question a lot. So there is actually some land underneath the ocean. So if you imagine you're on the Earth, and you're in the center of the Earth, and you kind of come up to the surface, maybe at the North Pole. First, you'd be at the very center where it's really warm, then you'd go through a rocky layer, then some water, and then the ice. That layer structure is very similar to what we see on Europa. So underneath the ocean, there is this big rocky mantle. And actually, we think that there may be hydrothermal vents on the floor of the ocean, just like there are on Earth, and that's where life may exist.
Wow. Okay.
Yeah.
We can probably squeeze in one more. This one's also on Instagram. Do rockets travel at the same speed in outer space?
It's a great question. So when they're traveling through the atmosphere, the air slows them down. They have resistance from the air. But once you get into space, you can go a little bit faster for the same amount of, boost. Additionally, once we get into space, our spacecraft is going to go about somewhere between 10,000 miles an hour and 100,000 miles an hour, depending on where it is in the solar system. So we kind of have a huge variety of speeds that we end up at getting out to Jupiter.
Wow. Thank you for that. Again, thank you for your questions. #AskNASA. Okay, we're coming up on another fueling milestone. Let's check back in with Daryl and Mick.
All right, thank you very much. And fueling going well right now. We're watching some telemetry on our screens right now. We've got RP1 on the first stage, about 75% complete, about 70% complete on LOX also on the first stage, but we're almost done loading the RP1 on the second stage.
Yeah, stage 2, RP1 load complete, should be finishing up here shortly and getting ready for LOX load on stage 2. So things
stage 2
continuing.
RP1 load is complete.
There we hear the call out for the complete of RP1 on stage 2, but things are moving forward. with propellant loading, getting ready for launch.
And now you see that LOX being vented out of the booster, which is condensing the warm Florida air here, which we have a beautiful day today, so it's really the only cloud that's in sight.
Yeah, it's a beautiful sight that you see there on your picture of on the screen of Falcon Heavy, looking really good as propellant load continues.
As we look up there, you can see towards the top where Europa Clipper, the spacecraft and the star of the show, is sitting inside of its fairing. You can see the NASA logo at the top, and on this view you can see the Europa Clipper logo, which is just below it, which is a pretty neat design that they made. I want to give you a little closer look at it. It was designed by the JPL team. Cynthia Phillips says she designed it to be something beautiful, something abstract and representational. We actually have a shot of that graphic, if we can pull that up, and there it is. It's a nice logo. The blue-white color scheme represents water ice, the elements on Europa being studied by the spacecraft. The shape looks like a snowflake or an ice crystal, and those two V-shaped portions represent the flybys, each pass of Clipper as it swoops in and then retreats. And then the dot in the center can be Europa, and the star shape can be the spacecraft. They put a lot of thought and design into this logo.
Yeah, it's a beautiful logo. Everybody is on board. It's just incredible to me how much the team, the community, and everybody's just excited about this mission and science, as Jenny was saying. And I know she's excited for this also, she and the JPL team. But beautiful logo.
Yep, looks good on a T-shirt and on the side of the rocket.
Stage 2 LOX load has started.
And there goes Stage 2 LOX load. So the final tank that needed to be filled has begun as we continue to make great progress tanking this vehicle. We'll send it back to Megan and Jenny.
Great to hear that tanking's going well. All right, NASA's ambitious journey to Europa has inspired U.S. Poet Laureate Ada Limon to write In Praise of Mystery, a poem for Europa. It is such a powerful piece. Please check it out.
In Praise of Mystery, a poem for Europa. Arching under the night sky, inky with black expansiveness, we point to the planets we know. We pin quick wishes on stars. From Earth, we read the sky as if it is an unerring book of the universe, expert and evident. Still, there are mysteries below. There are mysteries below our sky. The whale song, the songbird singing its call in the bough of a wind-shaken tree. We are creatures of constant awe, curious at beauty, at leaf and blossom, at grief and pleasure, sun and shadow. And it is not darkness that unites us, not the cold distance of space, but the offering of water. Each drop of rain, each rivulet, each pulse, each vein. O second moon, we too are made of water, of vast and beckoning seas. We too are made of wonders, of great and ordinary loves, of small invisible worlds, of a need to call out through the dark.
We had a little bit of technical difficulties there. The package paused a little bit, but I still think that you could really feel how powerful that piece is. And now we're so lucky to have Ada Lavone here with us. Thank you so much for being here. That was so moving. I was getting goosebumps.
Oh, thank you so much. It's such an honor to be here. Such a thrill.
I want to ask you, what made you want to write about Europa, and how did you find, truly the perfect words for that piece?
Oh, thank you. I think for me it was so incredible to be invited to write this poem. And when I was struggling with this incredible prompt and this incredible ask, I realized that it's not just a poem that's going to Europa, not just a poem that's on the Europa Clipper, but a poem that's for us. It's a poem for everyone here on Earth. And that was really important to me as I tried to choose the right imagery and the right language.
Mm-hmm. Not a tough ask at all.
No, not at all.
And not only that, but we're taking your poem with us. Yeah. So we have here a replica of the vault plate. This is the plate that's going, that is part of our vault on the spacecraft that's protecting all the sensitive electronics from all that radiation. And it's written in your own handwriting. Yeah. How does it feel knowing that a piece of you is going to Europa?
You know, one of the things that I keep focusing on is that it really is a poem for all of us. Mm-hmm. But when they asked me to do it in my own handwriting, my grandmother, who passed away a year ago, she was the one who taught me to really make my handwriting as perfect as could be. And every time I look at this piece, I feel like my grandmother is part of this project too.
I heard you had to rewrite it a few times to get it just right.
You think? Yes, many times.
The handwriting is as beautiful as the poem itself, I assure you.
Thank you.
And what do you hope people take away from this?
You know, I really hope that as we embark on this incredible voyage together, that we are reminded of the wonders all around us, that it's not just in these huge moments of exploration that wonders exist, but that they are everywhere around us all the time. Mm-hmm. And we can't be lonely if we are all connected to this universe.
Mm-hmm. Well put. Thank you so much. And one other note that I want to point out is, Jenny has always talked about this, that mix between science and art. Really, there is a connection there that we should be talking about.
Yeah, I think that it's so important. And in fact, we do ourselves a disservice when we separate arts and science because we're connected by curiosity and wonder.
Perfect. You are so well spoken. I see why you're the U.S. Poet Laureate. Ada, thank you so much for being here. We really appreciate it. And thank you for the beautiful piece of poetry you gave us for this mission.
Thank you. Thank you. It's been the honor of my life.
Thank you. Thank you so much. All right. So if you are inspired, really, as Ada was, to write about our universe and you want to write your own poetry, the QR code on your screen now is going to take you to a space poetry writing activity brought to you by NASA JPL. All right, another check of the clock. We are now 11 minutes, 51 seconds and counting from liftoff. Jenny, let's squeeze in a few more NASA social questions. What do you think?
Absolutely. I'm ready for them.
Okay, let's pull the first one up on the screen right now. This one is, how can we convert images to evidence of valid life in organisms? If it's proven, what are the next steps?
Absolutely. So, Europa Clipper is not a life detection mission, so we're not trying to prove that there is life there now. But what we are trying to do is characterize if this could be a habitable environment. And so, but even so, the images that we're going to get, we learn so much from images. Even just, looking at a photograph of the surface tells us a lot about the geology, why the surface looks the way it does. Those shadows, why do they look like that? That can tell us what's going on underneath that causes the surface to look that way. And so that tells us about the ocean. So there's a lot that we can infer from even just looking at images of the surface.
Yeah. Considering that you're talking about this, let's actually pull up a picture now. So, we said earlier that prior missions sparked our interest in Europa. Well, this is a 2022 pic from the Juno spacecraft taken from less than 310 miles above the moon's surface. And you see all those fractures. That's what Jenny was talking about, the fractures, the ridges, the bands that crisscross the moon's surface. From this image, that's how you guys discovered that maybe there is something happening underneath there.
Absolutely. It's part of how we Europa's surface is really different. There are some craters, but not very many. And that tells us that it is a kind of a young surface, at least geologically speaking, and that begs the question of why. So, that was one of the kind of avenues of scientific questioning that we had that led us to believe that there's water underneath the ice.
Right. So what else do we know about Europa? Well, it is Jupiter's fourth largest moon and only slightly larger than our moon. It's really, really cold at Europa. Surface temperatures range from about minus 210 to minus 370 degrees Fahrenheit. Scientists estimate its ice shell is 10 to 15 miles thick. And because of all that ice, Europa is 6 times brighter than our moon. The spacecraft now on internal power. There is strong evidence of our ocean, of an ocean beneath that icy crust that could hold over twice the volume of Earth's oceans. And then Europa orbits Jupiter every 3.5 Earth days, with the same side always facing the planet. That is super fast.
That is 3.5. Think about that for a second. 3.5 days to orbit Jupiter? That's so fast.
Yeah. All right, and let's take a look at the launch countdown again. We are now 9 minutes and counting until Europa Clipper launches, and no issues to speak of right now. The weather conditions are fantastic. I mean, take a look at your screen right there. Jenny, how are you feeling?
I am just absolutely buzzing. I'm feeling very enthusiastic, a little bit nostalgic, just so exciting. I'm really excited to get Clipper up into space where it belongs.
Yeah, I know this is super thrilling for you and the Europa Clipper team, but this is also a huge moment for astrobiologists and really the scientific community at large.
Absolutely. So astrobiology is kind of the study of how, life is distributed around the universe.
RP1 load is complete.
And so one of the things that, is really exciting about Europa is that it's a place in our own solar system that could be habitable. And so this, going to Europa to study it means a lot for the astrobiology community and, of course, for humanity at large.
Well, Jenny, here we go with the final moments of the launch countdown. Let's head over to Daryl and Mick.
All right, thank you very much, ladies. And here at Hangar AE, we are continuing to monitor the launch countdown. And so far, we're at T-minus 8 minutes and counting. We're listening to the launch teams. They are monitoring some temperature data coming from the second stage Lauches line that goes to the engine there. They're gathering data, so we're going to keep an ear and an eye on that. So far, everything else looks to be tracking okay.
Yeah, everything's proceeding forward with propellant load, and we did hear that stage 1 RP1 is complete on the 3 boosters.
RP1 load is complete.
So things are continuing to move forward there, and propellant loading will be finishing up here shortly as the team gets the vehicle ready.
The team at JPL in California also on console for their spacecraft, just shifted their spacecraft to internal power.
Yeah, they started transitioning everything to internal power. We'll get full confirmation of that in about 2 minutes, but things are good to go. And things are looking good on the preparations for the spacecraft as we move forward.
Engine chill has started.
There we hear the call for booster engine chill started on the 27 Merlin engines, getting ready for a liftoff at 12:06 p.m. today.
T-minus 6 minutes and 45 seconds and counting for liftoff of SpaceX's Falcon Heavy rocket with NASA's Europa Clipper spacecraft. At the very top, it is a beautiful day here in Florida for launching a rocket.
NY RP1 load is complete.
As we wrap up loading the RP1 in the first stage boosters, we've just seen all 3 go completely filled. Now we await for all 3 of the LOX tanks inside the first stage booster to get to their full point. You can tell they're most of the way there. As you look on your screen there, you see the icy cold rocket condensing that Florida air.
Yeah, the team's continuing to load second stage also with LOX, and we're getting very close. We can see on the telemetry here that the LOX load of the 3 boosters is getting near completion. The team is continuing to follow the procedures and look at the vehicle, make sure that we are good to go for a launch at 12:06. But things are progressing per the procedure, Daryl, and all is looking good for a great launch with this beautiful weather that we have at Launch Complex 39.
Coming up next, we are going to start configuring the tower, the strong back from the rocket. That happens in a little less than a minute.
We just heard from the SMD and NOM that the spacecraft is verified on internal power, and things are looking good for the Europa Clipper spacecraft.
We're also listening to the launch teams as they discuss the data coming in that they're looking at for the rocket.
Teams continue to follow the procedure, as I said, and work the loading of propellant, finishing up the topping of the 3 boosters and the second stage. As we mentioned earlier, the 3 boosters are expendable fully. They will not be coming back for landing today. SpaceX is getting the team ready to launch this vehicle today.
And you just heard the call out that the strong back is retracting. That strong back appears to have retracted. So we're getting some discussion on the nets regarding the second stage.
NY LOX load is complete.
As we just got completion of LOX load for the Y booster. We're looking for now the center core and the plus Y.
NLM, it's the LD on the countdown.net with a final status check.
Yes, LD, this is NLM on countdown 1, NASA spacecraft, and the NASA team is go for launch pending resolution of the anomaly.
Copy. Go pending outbrief of the issue being discussed on the anomaly net.
Affirmative.
Okay, Tim, so they've mentioned that they're working an anomaly. Tell me a little bit about it.
Yeah, so as we mentioned, they're monitoring some temperatures on the second stage, and things are the teams continue to look at that as they continue filling second stage with liquid oxygen. They're continuing to look at that and monitor that as far as they can into the count. So things are continuing to progress forward with LOX load. Center core is just finished up, so all 3 boosters are filled with LOX and RP1. The second stage has RP1 on, and we're getting near completion of stage 2 LOX load as the team continues to look at that temperature in the second stage. But we did hear NASA launch manager Tim Dunn tell Charlie Meyer, SpaceX launch director, that they are go for launch pending the resolution of this temperature issue. So the team has continued to work that. And the team will continue to progress forward in their procedure.
And so these discussions are happening very quickly as we are counting down now inside the final 2 minutes until liftoff.
Absolutely, and we just heard that stage 2 LOX load was complete, and the team is working that. And as you said, this is what they do in the last few moments before launch. They're working their procedures, following their processes, and having these discussions. But we are still progressing forward towards a T0 of 12:06, and things are progressing forward for the launch this morning, or this afternoon.
We are now 90 seconds until liftoff. Weather is 95% go. These boosters on the outside, they have flown before the Psyche mission a little more than a year ago. They are back on the pad along with a brand new center core booster and a spacecraft bound for the Jupiter moon Europa.
Yeah, Daryl, I can confirm, listening to the
Heavy
teams, that everybody is go for launch. They have resolved the temperature issue they were looking at on second stage. Everybody's given the go for that, and Falcon is in startup, so the flight computer has taken over, and we're getting ready for the
SpaceX
final
launch director is go for launch.
And there we hear Charlie Meyer say that SpaceX is ready for launch, and Europa Clipper getting ready to lift off.
And there's a great update as now it vents out the LOX inside the line of the transporter erector. We are inside of 30 seconds.
30 seconds and counting.
T-minus 15 seconds and counting.
And here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Liftoff of Falcon Heavy with Europa Clipper, unveiling the mysteries of an enormous ocean lurking beneath the icy crust of Jupiter's moon, Europa.
Engine chamber pressures are nominal.
See that the chamber pressures are nominal as we hear. All 27 Merlin engines look great.
Rocket beginning to roll. Putting down 5.1 million pounds of thrust. Coming up, they're going to back off those engines just a bit.
So we're getting ready to head into max
Power
Q.
and telemetry nominal.
We hear that power and telemetry on the vehicle are good there. Everything's looking really
Falcon
well.
Heavy is supersonic.
They have reduced power in the center core to get through max Q, maximum dynamic pressure on the launch vehicle as we approach that. The two side boosters at full throttle.
A beautiful shot there as our camera team.
Max Q.
Locking into the rocket on a clear blue sky. The view from the booster cam back down on Earth.
And there we heard the call for max Q. The vehicle is passing through maximum dynamic pressure. Next thing up in about 2 minutes will be booster engine cutoff, where we see the two side booster engines, all 18, shut down and get ready for booster separation. But the vehicle is performing very well. Looking at all the telemetry that we have, power and trajectory are nominal.
We've been flying for just under 2 minutes so far. Everything looking good. These side boosters, once they do their job, they will be expended. If you're familiar with the Falcon Heavy, you know that they bring the boosters back on certain launches, but not on this one, because all of the performance is needed to push Europa Clipper into its proper orbit.
Things continue to look good as the vehicle heads down its ascent phase here. All telemetry is looking very nominal for this flight this morning. Falcon Heavy is performing very well.
Now we're just about 30 seconds away from separating those side boosters. Their engines will cut off first, then they will separate.
MVAC is chilling.
Starting to chill down that MVAC-D engine in the second stage.
And that's where we need to get the engine chilled to the proper temperatures before flowing liquid oxygen and RP1 into it. So they're conditioning the engine to make sure things are ready for when it's ready to start up.
Stand by for booster separation.
Booster engine cutoff. Side booster separation confirmed.
And there they go.
Those two boosters previously flown on Psyche. This will be their 6th flight. We thank you for their service this morning. They did a great job of getting Falcon Heavy and Europa Clipper on its way as the center core takes over and continues mission down its ascent. Things are looking really good in the telemetry. Power and trajectory look nominal, and chamber pressures on the 9 center core engines look really good.
In just a little more, 20 seconds from now, we'll get the cutoff of the main engine on the center core booster that remains. 4 seconds after that, we will separate. Flying out over the Atlantic Ocean. There's a look from inside.
There we see stage 1
Stage separation confirmed.
And stage separation from the center core. Getting ready for MVAC startup, SES-1.
We're getting some applause here in the Mission Directors Center, and there you see the MVAC-D engine lighting up.
Next thing up in about 10 seconds will be fairing separation.
NYPY FTS has saved.
And the fairing has protected Europa Clipper on its ascent up into space, but once we get into space, we don't need that fairing anymore.
Fairing separation confirmed.
fairing has separated, and those will be recovered, Daryl, by SpaceX's own recovery ship, Go Cosmos.
And there you see them falling away into space. That is the only part of this rocket that will be recovered.
The glow of the MVAC-D engine as it performs its first burn here. This is about a 3-minute and 47-second burn. Things are looking great. Matter of fact, this is one of the shortest first burns that has been done on a Falcon Heavy by SpaceX, but it is required to get us into that parking orbit for that long coast that we have to get ready for the interplanetary trajectory that we're going to need to get Europa Clipper on its way that we heard Jenny talk about to get those Earth assist slingshots as it heads on its way for its mission. So things looking really good this morning with the performance of the Falcon Heavy. MVAC is performing well, and everything looks good thus far in today's mission.
Usually those burns are the other way around, with a longer first burn and the shorter second burn, but in this case it is reversed. As we look at some crystal clear views of the MVAC-D engine, the stage 2 that's carrying Europa Clipper, orbital light is shining both on the spacecraft, the second stage, and on planet Earth.
Center core FPS
beautiful.
has saved.
There we've heard that the flight termination system on the center core has been saved as it heads back to splash down. Things are looking good. I can tell you, Daryl, we had a beautiful weather day for launch, and as we're looking at MVAC flying in space with Europa Clipper, it is such a gorgeous view with Earth behind it, and so we could not have had a better day for a mission launch today.
No doubt about it, Mick. It was simply gorgeous. We had a hurricane a week ago, but after that pushed out, it brought us in its wake near perfect weather for launch. And now we're into space, dealing with the harsh conditions up there.
Stage 2 FTS is saved.
Stage 2 has made its way into space, far enough away for us to be able to safe the flight termination system from a safety perspective. We're about a minute away from second stage engine cutoff as we'll see the MVAC-D shut down and get ready for a long coast, getting Europa Clipper into that parking orbit and on its way for the next firing that we will have, the second stage, number 2, to get it into that interplanetary transfer orbit that we need to get Europa Clipper started. So things looking very well this morning. We're about 30 seconds from that stage engine cutoff, which we refer to as SECO 1.
That's right. We'll get into that. Guidance. Get into that coast phase. These views brought to you, of course, by ground stations across the track that are pulling in the high-resolution data from the cameras. Burn looking good, just a few seconds away from cutting off from that first burn. And there it goes. The first burn is complete.
Yep, things look really well on the stage burn result. Apogee, perigee, and everything for the mission looks really good. Engine performance, very well performance by the second stage for this first burn. And things continue to look good as we head into this long coast for this parking orbit.
It's a long coast, and we'll hit that second burn. Roughly 3 minutes and 21 seconds long. This one was roughly 3 minutes and 9 seconds. And Mick, you saw the data from it. It all looked pretty good. Then there you go.
Yep,
confirmation.
We're hearing confirmation that we have nominal orbital insertion as we were looking at the telemetry here, Daryl. That things looked very good. Stage 1 and Stage 2 performed very well on that ascent flight. And we'll continue to follow Stage 2 to get ready for that second burn. And then, of course, what we're really looking forward to, Europa Clipper separation.
It's going to be a beautiful moment. If the pictures are as clear as we've seen so far, we will see it in all of its glorious detail. All right. We will continue monitoring the coast phase of the second stage with Europa Clipper. And we will bring that to you. Of course, any updates that we have, we'll check back in with you in a little bit. But for now, let's send it back to the host desk with Megan and Jenny.
Oh, wow. I mean, if you're just joining us, welcome live to Kennedy Space Center in Florida, where we just saw a SpaceX Falcon Heavy rocket soar off the launch pad with the Europa Clipper spacecraft. I thought... I'm surprised you're here and composed, to tell you the truth.
Yeah, you did a good job of keeping me upright watching the launch.
Yeah, how are you feeling? How was it to see that and feel that, too? I mean, that was honestly one of the loudest and most powerful rocket launches that I've personally felt here on the Cape.
It was very emotional in a good way, right? Just kind of overwhelming with just the awe of it, and that it's finally going up into space. And I feel almost at a loss for words.
Yeah, I know. She was like, I am sobbing. She just kept saying, I am sobbing. I am sobbing. I mean, but everybody can understand that, right? I mean, and this is one of my favorite parts of being part of the broadcast, because I do get to watch it with the co-host. And really, this is so much of your life that you're seeing culminate in a rocket launch.
It is. It's a huge, again, it's almost indescribable, just the amount of time and effort and all the people involved that got us to here, and to witness that moment is just unlike anything I can describe.
And can you believe it? We are still very much at the beginning of this spacecraft's journey. It is headed for Jupiter's icy moon Europa, which scientists believe could be the best chance of finding the ingredients for life outside our planet. It will take the spacecraft 5.5 years to travel the nearly 2 billion miles to Europa. This is a mission developed by NASA's Jet Propulsion Laboratory in California and Johns Hopkins University's Applied Physics Laboratory in Maryland. Now, Jenny, why does the team think that Europa is the best chance of finding those ingredients for life as we know it?
Yeah, on this planet, everywhere we find water, we find life. And so, that we think that there's this massive ocean of water underneath the ice on Europa is just, how could you resist, So we think that Europa has that water. That's one of the key ingredients for life, along with the chemistry and the energy and the time. It's been kind of simmering away for a long time.
Sure.
It's a great place to go explore.
And how exciting would it be, right, if we could verify that there are the makings of life as we know it on Europa? So let's dig into the science that is going to make this possible.
We have several ocean worlds in our solar system. And by exploring Europa, we're getting a taste of what these ocean worlds are like. Europa probably has beneath its icy surface a global ocean of water.
We think there are thermal vents in this vast subsurface ocean. There may be primitive organisms there, similar to the original primitive organisms on Earth from which we all evolved.
I just love Europa's surface. I think it's one of the most complex surfaces in our solar system. Typically, when you look at another planetary surface, it's covered with craters, just like our moon.
There are shockingly few impact craters. So that means something is going on to erase the craters, just like happens here on Earth, and on Earth we call that geology. One of the key questions right now that we have about Europa is whether or not there's plume activity.
Plumes are one way that you can definitely get ocean material to the surface. We really need a spacecraft in the system that's watching Europa to see when those plumes are happening, if they're happening. Europa Clipper is orbiting Jupiter, and it's performing 49 flybys of Europa.
Each time we make a flyby, we turn on all of the instruments at once.
Most of us know about cameras because that's what our eyes see, but there is a whole slew of other instruments on board Europa Clipper that expands our vision.
We have 4 different instruments that we're really using to take images of Europa's surface. We have the visible wavelength, the near-infrared, the far-infrared, and the UV, the ultraviolet.
We're hoping to see evidence of change, new cracks, new surface colors that indicate different materials maybe have moved around or come up from the subsurface.
We have an instrument that can sniff the very thin atmosphere, the gases, and determine the composition with extreme precision. And we have another instrument that can tell us the composition of dust particles.
We have a magnetometer and a plasma instrument that are going to be studying that magnetosphere environment that Europa is sitting in and Jupiter's magnetosphere environment.
The magnetic field of Europa, in turn, can tell us about the properties of the ocean. How thick is it, and how salty is it?
And then we have this novel ice-penetrating radar that will try to get below the ice shell.
last but not least, we have a gravity experiment using the communication system of the spacecraft. And from that, we can get essentially a map of the gravity field.
We can get the shape, understand, what's underneath, maybe even get some information on the depth of the ocean. It's really a sophisticated payload.
The pictures that we are going to get back are going to be just fantastic.
The legacy of Europa Clipper will be just a treasure trove of knowledge about this world.
Just to find an environment that is similar to the one from which life arose on Earth would really be groundbreaking. It would be awesome.
We don't know if Earth is the only place that life got started or if it's really common. And a really important way to get at that is to understand, is there life elsewhere in our solar system?
And we were proud to host JPL directors here at Kennedy for launch. She's with Tony now, and they both had a spectacular view of launch.
That's right, Megan. What a spectacular sight indeed. And like you mentioned, we have a very special guest with us, JPL Director Laurie Leshin. Laurie, congratulations first off on what a beautiful launch and now an exciting mission ahead.
What a great day. We're so excited. Thanks to SpaceX for the fabulous ride.
Absolutely. And, Laurie, what would you like to say to the teams who have put in so much hard work and dedication, to this mission?
More than 4,000 people across many different organizations have worked on Europa Clipper, and we're so proud of them and so grateful for their hard work, for their families who've supported them, and especially the 150 or so with us from JPL who rode out the hurricane here. Thank you.
Absolutely. And, can you tell us a little bit more about why planetary missions are important in general that we go and study?
Well, it's really about who we are. Even though it's a robot we're sending out into space, it's a very human endeavor to want to explore the unknown, and especially to want to understand where life came from, how we originated, whether there could be other life out there. It's really a fabulous quest, and we're so fortunate to be able to do that through NASA's science program.
Definitely. And, can you tell us a little bit more about the Europa Clipper vault plate and why teams decided to include one?
The vault plate is so wonderful. It builds on a great history. People know about the Voyager Golden Record, which carried messages from Earth into deep space. It's kind of following in that tradition, and to have a special poem written by Ada Limon, the U.S. Poet Laureate, we're over the moon, over Europa, about being able to carry her words with us and to carry 2.6 million names of Earthlings with us as we go explore Europa.
Absolutely. A lot of special mementos on there indeed. Now that launch has occurred, what are some of those key milestones that the teams are going to be looking out for on its way, on Europa's way to Jupiter?
Right. So just today, we'll be looking about 1 hour out is when we separate from the upper stage of the rocket. 3 or 3.5 hours out is very important because that's when our solar arrays, those giant size of a basketball field or basketball court solar arrays, deploy. We need those because we need power. And then in just 4 months' time, we'll fly by Mars for our first gravity assist. So it's going to be excitement all the way along on our way to Jupiter.
Absolutely. Laurie, thank you so much for joining us again here today. Back over to you, Megan.
Thank you to Laurie and Tony. And now I want to bring back Raquel, who's live at NASA JPL in California. I know the team, like here, erupted into cheers when the rocket lifted off. But now, Raquel, they're back at work and looking forward to what's next, right?
That's right. There was lots of cheering over here, but now here is a live look from inside Mission Control. You can see the team is getting ready for Europa Clipper's next milestone. Now, we showed you them gearing up for this moment, and now they wait for acquisition of signal, but there's a lot happening in there that you can't see. That's why I caught up with mission manager Tracy Drain. So let's take a look at a behind-the-scenes breakdown.
And Tracy, tell us about the space here in Mission Control.
Here in Mission Control, you'll see a lot of folks who are paying attention to the configuration of the spacecraft before launch. But our main role is to catch the baby, that's Europa Clipper, so that we're ready to control it once it's well on its way.
And you'll be right up front here with your headset on, talking to everyone in the room. Can you tell us what is going on behind the scenes?
Sure. I, as mission manager, am making sure everything's running smoothly here and communicating status to our project manager in Florida. Next to me is the flight director, whose job is to do what their title sounds like, direct or guide the people in the room through the detailed steps of the procedure.
So if the flight director is guiding the room, who in here is talking to the spacecraft?
The primary engineer talking to the spacecraft is the ace. They're paying attention to the link between the spacecraft and the deep space network on the ground. They actually get to hit the button that sends commands to the spacecraft when we're ready to do that. Behind them is telecom, who is responsible for all the hardware on board, the radio, making sure that that's working so the spacecraft can communicate to the ground. And there are some other roles too who are ensuring that the data from the spacecraft is coming to this room properly. The phase lead sits over here, and her job is to understand all the things that are supposed to happen before and during launch, so that if things start to go a little sideways, she'll be heavily involved in making sure we understand how to deal with them. Navigation are assessing and understanding the track that the spacecraft is on once it separates from the launch vehicle, so that the antenna on the ground can point to it and track it.
And then this row behind you, they're making sure Europa Clipper is healthy, correct?
That's right. While systems here is ensuring that all of the different parts of the spacecraft work together, the folks back here are paying attention to individual pieces. Avionics and flight software are paying attention to the computer and the software that's running on board. Fault protection is ensuring that if something ran on board in response to a problem, we understand what that is. Power is ensuring things like the solar array and the battery are producing enough energy for the spacecraft. Thermal is making sure that everything stays within the right temperature ranges. Propulsion is noting everything that has to do with thrusting on the spacecraft is working. Then guidance, navigation, and control and motion behavior are ensuring the spacecraft is pointed in the right direction and moving the way that it should.
And there's a special role here too, the test bed. Can you tell us a little bit more about that?
Yeah, the test bed is a set of hardware and software components in another room that we have two of them set up like a simulation of the spacecraft, so that if things go a little bit off kilter, then we can use them to troubleshoot what's going on.
And there's one more thing I'd like to ask you about. There is a tradition here at JPL that involves some snacks. Could you tell us more about this?
That's right. These are the Lucky Peanuts. And as the story goes, back in the 60s, an engineer was handing out peanuts during a launch just to ease the tension in the room. That one went really well. And so now, as our tradition is, we have Lucky Peanuts with every major event. Lucky Peanuts.
Thank you so much, Tracy.
Absolutely. It's my pleasure. Thanks for having me.
As you can see, Tracy is here now, and the entire Europa Clipper team are in high gear. This isn't the only room where the team is hard at work. Let's take a live look at an additional operation room. This is where an overflow of the team is working during and after launch. Megan, back to you.
Thank you so much for that video and tour, Raquel, because it really was cool to see all the people, again, that is making this mission possible. And we have even more people for you all to meet. Take a look.
Humans can be pretty smart, and we do discover a lot of great things, but there is still so much that we don't know.
This is like one of the most exciting times to be working in space.
I feel very fortunate and privileged to be supporting this mission.
Europa Clipper is NASA's flagship mission to explore a moon of Jupiter called Europa. Here's our Europa Clipper spacecraft being built.
How do you build a spacecraft to go visit a world that exists inside of this extreme environment?
What we're looking for is what's underneath the surface.
My name is Valeria Salazar, and I help put together all the hundreds of different components that make up Europa Clipper.
My name is Andres Rivera.
My name is Jenny Kampmeyer.
My name is Sarah Elizabeth McCandless, and I am an interplanetary navigator.
I'm Deepak Srinivasan, and I work to make sure that we can communicate with the Europa Clipper spacecraft.
And making sure that Europa Clipper makes its way to Jupiter safely.
I work on Europa Clipper, helping science fiction become science reality.
We're going to Europa to determine whether we have favorable conditions for life.
Here on Earth, no matter what environment you're in, wherever there's water, we found life.
We're going to investigate all those ingredients that we think have led to life as a whole.
But to actually do that, a lot of engineering has to happen.
There's no one person that is responsible for getting this spacecraft built, for designing our science campaigns.
I'm helping enable solar system exploration, helping to enable exploration of the universe.
We're doing some really humanity-changing science.
It's a hard journey to get here. It felt like an impossible dream.
For me personally, being an immigrant and I never really imagined that I would have the opportunity to participate in something like this. Just seeing it up here and knowing that it's going to be up in space, it's pretty humbling.
Seeing it from its infancy to actual realized hardware, to get that on its journey to Europa, it's just going to be a wonderful feeling.
It's been very motivating to see that a part of me will go to Jupiter.
I'm contributing this tiny part of something that's going to help us understand better about our universe.
We're going to be exploring literally the frontiers of life.
Who knows what mission today is going to be that inspiration for the next generation.
That's such an honor to be a part of.
Jenny, I love how emotional you get every single time we see some of the members of your team. And what's incredible is, we did meet a lot, but that's still a fraction of the people who work on this mission.
Absolutely. And it's like a fraction of a fraction of a fraction. I mean, we totaled it up recently, and there are thousands of people who have worked on this project over the years. So it's amazing.
Well, and you said some people have been working towards this mission for 25 years. So that is really easy to believe.
Absolutely. And every single one of them has worked really hard for this day.
Wow. And Europa Clipper is the largest spacecraft NASA has ever developed for a planetary mission. Let's bring back NASA's Antonia Jaramillo.
Thanks, Megan. Joining me is Dr. Robert Papalardo, the Europa Clipper project scientist. Bob, what exactly are we expecting to find, with this Europa Clipper mission?
Well, the Europa Clipper carries the most sophisticated suite of instruments that we've ever sent to the outer solar system. It carries a radar that can penetrate through ice like a CAT scan to find liquid water. Super high resolution imaging. We'll be able to look for warm spots, plumes at Europa. All these wonderful techniques that combine together to tell us, could Europa be the kind of place that could support life today?
That is very exciting. I mean, can you tell us a little bit more about how scientists will indeed confirm that Europa can support life, like you said?
Sure. We want to understand whether Europa has the so-called ingredients for life. Liquid water, the right chemical elements, and then the energy that could support life. So understanding Europa as a whole can tell us whether those ingredients are there.
And Europa's an ocean world. What kind of ocean are we looking at here? Is it going to be one like Earth that has, a variety of warmer, cooler waters, or are we looking at something entirely different?
Probably not too dissimilar from cold oceans at Earth, Arctic oceans, but here covered with a layer of ice. But the temperature will be similar to Arctic oceans, probably salty. We're not sure how salty. And the pressure at the bottom of Europa's ocean is probably similar to the pressure at the bottom of the deepest point in Earth's oceans. Earth has a lot more gravity, but Europa's ocean is a lot deeper.
That's very exciting. Now that Europa Clipper has launched, how does it feel for you, Bob, for the teams and everything now to see this mission on its way?
Just overwhelming. That launch was incredible. And here we are. It's the culmination of so many years of work by so many people. And now we're on our way. And 6 years from now, we'll start getting great data from Europa.
That is so exciting. I know all of us here are very much looking forward to that. Bob, thank you so much for joining us. We'll send it back over to you, Megan.
And actually, Jenny, you and I were just talking. Bob is one of those people who has been working on this for 25 years.
25 years, right? And this is really kind of I know how much this moment means to him to finally get here. And him and, obviously many of his colleagues as well. But 25 years, can you believe that?
Yeah, again, very composed for someone who, all of you are very, very composed. All right, so NASA made a point to keep the spacecraft as clean as possible before launching to its destination. Here's why that is so important.
I have the coolest job on Europa Clipper. I keep the spacecraft biologically clean. This means I am looking to reduce the amount of bacteria that are stuck to the spacecraft.
Akemi and her team need to keep the spacecraft as biologically clean as possible to help protect this environment as well as the other planets and moons Europa Clipper will encounter.
We're really helped by this awesome clean room here. It does a lot of the work for us. We also monitor everything that's being brought into the clean room. Everything is very tightly controlled. It's cleaned before it comes in, and we sample anything that is going to come close to the spacecraft. We're sampling in 3 different directions, and each different direction gets a different face of this wipe. We want to give ourselves the best chance to pick up any bacteria that might be on here. This is the lab where we process all of our flight support samples. So I need to take this wipe that we use to sample the spacecraft surfaces and get it into this bottle. And then I'll add some soapy water to this. And then from there, we're going to shake off all of the bacteria into that soapy water. We are using sound to widely shake all of the last little bacteria off into our soapy water.
And then we've moved to the next step, heat shock. What we're trying to do here is kill off all of the weaker types of bacteria and leave just the hardy bacteria.
Next, we're going to filter this. The liquid will filter through, and the bacteria will stick on top of the filter. From there, we put that onto a plate of bacteria food. From there, we let it grow for 3 days. We count every 24 hours for 3 days. They are really diverse, actually. They come in different colors. They can be tall and ridgy or really circular and smooth. Some of them really spread out. We use that number to estimate the number of microbes living on the spacecraft. Think of Europa's ocean like a nature reserve. We don't want to contaminate it with anything from Earth.
Out of the thousands of samples that we've collected, only about a dozen have required us to ask the engineers to re-clean the hardware so that we could go in and resample it.
All right, let's go back to Daryl and Mick to get another status update on the rocket.
Yeah, and we've been following this launch ever since it lifted off at 12:06 in 00 seconds Eastern Daylight Time from right here at the Kennedy Space Center in Florida. We are tracking since then the progress of this coast phase, and we do not have telemetry data currently for it, but we are expecting to pick that back up at our next ground station. We're currently flying over top of close to, as you can see right there, the southern tip of Africa.
Yeah, Daryl, the telemetry and ascent coast is picked up by the ground stations across the globe, and we'll be picking up data here shortly. And one of the new things that we'll be doing with Falcon Heavy as we get ready to start up stage 2 for its second burn, we'll be using the NASA TDRS network, the tracking data and relay system, to be able to pick up that start of stage 2 once that comes about. So that's a first time we'll be using that for Falcon Heavy, and things are looking great. So we are hearing that we just got at AOS from our Cape Town ground station, and we were watching telemetry. It just came back on the screen, so things are looking really good. Data that has just popped up for the orbital coast looks good from a velocity standpoint and altitude. So this mission continuing to look good during this coast phase.
Right. We've regained, again, our telemetry now. We can see exactly where the second stage is and the spacecraft. All is good now. And you mentioned going to fly under TDRS when we lose all ground stations, so that we're going to use a satellite to keep track. All right. So we're back online now, and we'll send it back to Megan and Jenny.
And we told you earlier how the spacecraft's sensitive electronics are in a special vault to protect them from Jupiter's intense radiation belts. This is a piece or a replica of a piece of that vault. And as we said, it has U.S. Poet Laureate Ada Limone's poem engraved on it. But also we wanted to point out this. This is a part of NASA's Message in a Bottle campaign. Can you tell us about it?
Yeah, so more than 2.6 million people signed their name onto Ada's poem and her message out to Europa and out to the stars. And not only that, these names are not they're not digitally encoded in a microchip. They're actually etched, this kind of micro etching, nano etching
on that
tiny
which is
little
like
chip.
The size of a dime.
Exactly, 2.6 million names actually physically etched onto this plate that was attached to the spacecraft.
Because I was incredulous about that, I was like, really? So I did find out that JPL technicians used an electron beam to stencil all those names, and each line of text was smaller than 1/1000th the width of a human hair.
Yeah,
that is wild.
Absolutely wild, right?
Yeah, take a look at the video now. This is them actually stenciling, like you said, those names on there. And I just love how many people, again, as you said, 2.6 million wanted to take a part in this and have their names go into space.
It really is incredible that, the public got so excited. Everyone wanted to send their name along Europa Clipper out to Jupiter.
And just really quick, let's come back here live to the desk. Can you flip over the vault plate? Because there's so much in with this vault plate. We want to point out the other side as well.
Yeah, so the other side of the vault plate has the word for water in about 104 languages. And these are the audio waveforms of people saying the word water.
Wow.
Because water is the thing that connects our two worlds, connects the Earth and Europa.
Yeah. What a beautiful way to embody this mission, really, in this vault.
It really, it's really incredible.
That's cool.
Yeah.
Okay, so the Message in a Bottle campaign was just one of several ways you could be involved in this mission. Some of you took part in an art challenge, so let's take a look at some of those pictures now.
Oh,
that's nice. It's so colorful and beautiful. And Mize is one of the instruments,
Mize
right?
is one of the instruments, and we love saying things like "Go Mize, go!" "Go Clipper, goes." That's amazing to see. Oh,
oh, that's great.
Oh,
so
wow.
what a creative imagination. That is what folks or this child is hoping to maybe see on Europa, right?
Yes, and in kind of our wildest dreams, we hope we see things like that.
A narwhal, yeah. Oh, this is really nice too.
Cool. Yeah, look at that. So that's kind of showing our trip out to Europa, and I love that kind of side view of Europa, seeing the ice and the water underneath. That's amazing.
And you know, if you're home watching and you're saying, wait, I want to submit my picture, my masterpiece of Europa Clipper, there's still time, so just take out your phone and scan the QR code now that you see on your screen. The art challenge is open until the end of the month. Or if you like to wear your love for Europa instead, let's take a look at some other photos now. These are Jupiter and Europa-inspired fashions, and this was part of NASA's Style Challenge #Runway to Jupiter. They look very happy to be wearing the mission logo.
That's awesome. Those look like, I think, knitted or crocheted sweaters.
Oh,
wow.
This is my Halloween costume.
I could see that.
I'm going to dress up as Jupiter, and you're going to be Europa and just run around me.
That's great. Every 3.5 days, I'll run around you.
Oh, and these nails are pretty too. It's always nice to see, ways that people can bring their excitement for this mission onto fashion or art or anything like that.
Exactly, and connecting kind of their own creativity with science. Speaking of which.
And those nails, I feel like, put us to shame.
I know.
Jenny and I bonded. We did some co-host bonding, and we got our nails done as well. You see, they're meant to look like the ocean. So.
That's right, a little watery blue marbling.
Yeah, so I hope you also liked our runway to Jupiter submission for y'all to consider. And if you want to check out some more of those fashions, those Jupiter and Europa-inspired fashions, again, we have another QR code for you now. Trust me, there are so many more creative expressions worth checking out that really capture Jupiter's swirls, Europa's icy glam, and the exploration of our solar system. All right, and now we're going to go over to JPL. We have another update from Raquel.
That's right, Megan. We're now taking a live look at another part of the Friends and Family event, this time in JPL's Von Karman Auditorium, where we saw lots of cheering during launch, and among those celebrating are the family of Al Kangahuala, the deputy joins us now. Thank you so much for joining us. Al, can you tell us about your role and the next few weeks for Europa Clipper?
Hello, Raquel. Sure, happy to. Along with Tracy Drain, we take turns in early operations, shift by shift, as you were mentioning, ensuring the health and safety, not just of the flight system, but of the mission operations engineering teams that are making this all happen. Looking ahead past today, we have many activities ahead. We're going to be performing characterizations, deployments, and checkouts of the subsystems and instruments. Some will be required prior to our first trajectory correction maneuver in about 3 weeks. We call that part Flight System Characterization Part 1. And then the vast majority of the remaining checkouts will be performed after that. That'll put us kind of near the end of the calendar year. After that, we'll be performing a flyby of Mars on March 1st, 2025.
Speaking of flybys, Europa Clipper will have flybys of Earth and Mars. So how does that help it reach its final destination, Jupiter?
So we use planetary flybys to perform what you would consider to be like gravity-fueled maneuvers. The slingshot effect you get by flying by a planet or a moon gives us essentially the ability to add energy to the spacecraft trajectory and to put the trajectory in a more optimal direction. So to get to Jupiter, we'll perform flybys of Mars next year and then one of the Earth in December of 2026 prior to arriving in Jupiter in 2030. Of course, once we're in the Jupiter system, we'll be performing many
Object. So looking under light without the flashlight, it looks
really amazing what you see the science in front of us immediately. That was really cool. Thank you for that.
Awesome.
So again, these are just some of the 9 instruments that Europa Clipper has on board. We're going to show you the other 5 after.
The spacecraft is huge. It's going to a destination that you could really just dream of. You know, think about the moon, but the moon, you know, our Earth's moon, but with twice the volume of water that we have on the Earth. And our spacecraft's going there to explore. It's a very large spacecraft, very heavy spacecraft, and of course soon our magnificent solar arrays are going to deploy. These solar arrays are 100 feet across. So this is the largest, most significant planetary science mission of all time.
That's right. And can you tell us a little bit more about APL's contributions to this mission?
Yeah, well, a mission this unique actually took the best of the folks at the Jet Propulsion Laboratory and at the Applied Physics Laboratory working and learning together. This mission took the best of all of us to get this done. Here at APL, we've been responsible for the propulsion module and the communications electronics and antenna that are part of that module. The propulsion module is about 10 feet tall. It's about 2/3 of the height of the overall spacecraft. And we've also built, I'd say 2.5, 2 and parts of 1/3 of the science instruments. So the cameras that we were just talking about, those 8 megapixel, both wide angle and near angle cameras that were, when they were designed, had the same resolution as, say, an iPhone 10. Those were designed right here at APL. They're going to be able to zoom in on Europa to a factor of 5 greater than what we've seen on past missions like Galileo. We also built the PIMS instrument, which is one of 2 instruments that's looking at the magnetic field and the plasma surrounding Europa. It's going to tell together, they will tell us a great deal about the ocean beneath the icy surface. And then with JPL, we worked on the MISE instrument, which is that spectrometer that you were just talking about in the previous segment.
That is very exciting indeed. I know we're all very much looking forward to the data that we get back from those instruments. Bobby, thank you so much for joining us. Back over to you, Megan.
Really cool to hear from APL, and thank you, APL, for your contributions to this mission. As promised, we now have models of the remaining 5 instruments on Europa Clipper. So, Jenny, what do we have now?
Yeah, absolutely. So we're going to start over here again.
Okay.
So now these 2 instruments, that furthest one is SUDA, And then both of these together are our dust detector and a mass spectrometer. So these instruments are going to be kind of directly tasting particles that are in the environment around the spacecraft.
Tasting?
Yes, so kind of as we're flying past, particles will be hitting their sensors and we'll be able to tell what they're made of, how fast they're going, and doing that kind of chemical analysis.
Oh, okay.
The three over here that we have photos of, because they're really big, so we can't have
You couldn't
models.
fit them on the desk?
That's right, they wouldn't fit on the desk. The three of these together are going to be able to tell us about the interior structure of Europa. So we'll start on the end with Reason. Reason is our ice penetrating radar.
Okay.
That's going to help us understand how thick the ice is, places where it may be thinner. And then PIMS and our magnetometer are studying the plasma fields and the magnetic fields. So let's talk a little bit about the magnetic fields,
Okay.
because this is a really interesting part of Europa.
Uh-huh.
So let's do a little demo.
Okay.
So I want you to hold this.
All right.
We're going to pretend this is Jupiter.
Right.
And you can see there's kind of a magnet inside with some of these iron filings. So go ahead and give that a quick shake.
Mm-hmm. Oh.
Oh, yeah, shake it up real good, real good. There you go. Awesome.
Okay.
So now, it might be hard to see, but you can see that that iron is flowing around like the magnetic fields of
Yeah.
Jupiter. So if you were to just take a rock and move around, you wouldn't really see much, but try it with that.
A magnet.
Yeah, so that one's magnetic.
Whoa, it's
Yeah.
attracting all the little metal shavings.
Exactly. So that's basically, we're kind of pretending that this is Europa in this situation.
Uh-huh.
So the way we discovered that there was an ocean underneath the ice is because there was a little bit of a wobble in the magnetic fields.
Uh-huh.
And we were able to infer from that there must be some sort of conductive layer underneath the ice.
Ah, I
And
see.
so if Europa didn't have that conductive layer of ocean, we wouldn't see this kind of interaction with the magnetic fields.
Gotcha.
So our
Okay.
magnetometer instrument that we have on the payload is super, super important.
Awesome. Thank you so much, Jenny.
Yeah.
All right, so we've been following along with the Falcon Heavy second stage as it continues its journey out with Europa Clipper. So let's head back to NASA's Daryl Nail and Mick Waltman for the next operational milestone.
Yeah, that's right. We're getting ready to relight the second stage engine on the second stage of the rocket, carrying Europa Clipper, and it is just moments away, Mick. We're at T plus 47 minutes and 30 seconds, getting ready to relight. This is a longer burn than the first burn.
Yeah, this is the burn that will get us into that ITO, or interplanetary transfer orbit, allowing down prior to this, and ignition has happened, and the second burn is continuing on.
So this is a 3-minute and 21-second burn of the second stage. If you're familiar with the amazing views that we have at this point, then you know that we've got the camera on the second stage. However, we are not expecting to see that view for this particular burn, and there's an important reason for that, and that is because we've been on ground stations leading up into this point, but for the duration of this second burn, we are pulling data through the TDRS network. The TDRS network, a legacy satellite system in geo orbit that is going to help us out fill in the gap so we can at least pull down the important telemetry of what is going on.
Yeah, we're seeing the telemetry coming through, and things are looking good on the telemetry. And but as you stated, we can't process that video through there from that aspect, and things continue to go for this burn.
Yes, the TDRS system covering 90% of this burn too. TDRS, of course, standing for Tracking Data and Relay Satellite Network. 90% of the burn will be covered by TDRS, but it's a much lower data rate than it is from the ground station. It's roughly on the order of 20 kilobits per second. If you compare that to your home internet connection, it's the pipe is about 5,000 times smaller.
Yeah, we have to choose what data we send. So we want to send the vehicle telemetry so we can see what's happening from a stage 2 velocity and altitude, and bandwidth for video takes up a lot more. So we opt to get the launch vehicle data, and things continue to look good for this burn.
Anyone who has downloaded video onto their phone knows about bandwidth. You got to have a good connection. You got to have a cell phone that's on a wide connection in order to pull down video. So we will not have video for any part of this second burn. Also, the spacecraft team is not getting any of the telemetry being pulled down because, again, as you said, there's a high priority on the communications about where that rocket stage is.
Yeah, absolutely. And this bird burn continues, and we're about 30 seconds away from the end of this burn, and we'll see how things continue to move. But we're watching the telemetry here, Daryl, and you can see that the acceleration of stage 2 and velocity continue to increase as stage 2 is performing its job to get Europa Clipper into its orbit.
MVAC engine cutoff.
There you have the cutoff. The second burn is complete. And we just caught some video of right there at the end of the second burn, and we've got some results there, everything looking good.
Yeah, TDRS network did its job. We just switched over to ground station, and we were able to pick up that
Nominal
video.
orbit insertion.
And nominal orbital insertion has just been reported, and stage 2 looks good. So our next event, Daryl, will be spacecraft separation. Very excited for that, and I know everybody's looking forward to that with the successful launch today.
We are looking forward to seeing Europa Clipper go off into space off that second stage, but in the meantime, we'll send it back to Megan and Jenny.
All right, it's been now about 51 minutes, nearly 52 minutes since launch. Our coverage is going to take you through separation and getting the first possible signal from the Europa Clipper spacecraft. Let's head back over to JPL, where NASA's Raquel is somewhere new to tell us about the Deep Space Network.
Yeah, Megan, this is a wider look at the Space Flight Operations Facility at JPL, where NASA operates the Deep Space Network. This powerful system is able to communicate with spacecraft traveling beyond the moon. And joining us today is Amy Smith, the Deputy Project Manager for the Deep Space Network. Thank you so much for joining us, Amy.
Thank you for having me.
So your team is waiting to hear from Europa Clipper. Can you tell us why the Deep Space Network is so important with establishing communication with spacecraft?
Yes, so the Deep Space Network is part of NASA's Space Communication and Navigation Program, and it is the critical link between scientists and mission controllers on the ground and more than 40 missions that are exploring our solar system and beyond today. So the Deep Space Network is made up of 14 very large antennas strategically located around the world. We have a complex here in Southern California, one outside of Madrid, Spain, and another one in Canberra, Australia. And those are about equidistant around the world, as you can see in this graphic, so that wherever your spacecraft is, when it needs to communicate to Earth, it can see one of our Deep Space Network antennas. So with the Deep Space Network, we can send commands to our spacecraft, we can collect all that amazing science data, and we can even collect navigation data so that the teams know where the spacecraft is.
Yeah, and what is Europa Clipper doing right now, and which location do you expect to establish communication with first?
Yeah, so the radio on the spacecraft will turn on about its separation and start warming up and sending a downlink signal back to Earth. And we have antennas at our Canberra complex, which are set up right now and waiting for that signal.
And then after that, what is your team doing to prepare for signal acquisition before and after?
Yeah, so the Deep Space Network is here to support our missions. And so we work really closely with the missions to understand what they're going to need, especially in a critical event like today. The mission provides all of those parameters to the Deep Space Network so that we can set up our antennas to be looking at the right place in the sky, to have all of those downlink set up just perfectly so that when the signal comes in, we'll be able to see it. So the first thing we're going to see with our antennas is the carrier frequency. We'll see that pop up and we'll lock onto that. And then we can start to decode the data that's on there. And once we are able to decode data, we'll start sending that directly to the mission operations team so that they can use the data to see what's going on the spacecraft and make decisions about what to do next. Eventually, they'll ask the Deep Space Network to turn on the uplink, so we will establish coherent two-way communication, which means we'll still be collecting data, but then we can send commands to the spacecraft, and we'll start collecting that critical navigation data that the team needs.
Okay, thank you so much for your time, Amy. Megan, back to you.
Thank you, Raquel and Amy. And once Europa Clipper is launched, you can follow along with its journey using NASA's Eyes on the Solar System, which you can check out by scanning this QR code. It's a 3D program that allows you to zip around our solar system to learn about planets, asteroids, comets, moons like Europa, and spacecraft like Europa Clipper. And remember, Europa Clipper is not a life detection mission. Again, instead, it is looking for the right conditions that could support life. Now, a check on the clock. We are now 55 minutes from launch. We have time for some more social questions. This one actually is not a question. It's a well wish. This is from Tiffany Basket on Facebook. I think she knows you because she's saying, "Hi, Jenny." From all of us in Ohio at the Buckeye Online School for Success, we want to thank you for keeping us updated and inspiring our students to dream big. Good luck today.
That's just so heartwarming and amazing to hear from them. And I know they're all watching. So, yeah, thank you so much.
Yeah, that's wonderful to get to hear
great.
that. Hi, Tiffany. Thank you for that.
Yes, thank you.
And we have one quick one from Instagram. If life is found on Europa, what will be the next steps? What does this mean for future missions? And I'll add on to that. What would life look like possibly?
Yeah, so, again, we're not a life detection mission. We are not really looking for like a biosignature of something that says like, wow, we found life, right? But we are going to assess its habitability. And if we find that this is a place that is habitable, the hopeful next step is that we would send a landed mission, that we could go in the future and actually land on the surface, take samples and all those things.
All right, let's go back to Daryl and Mick right now.
Very much, and we continue to watch the progress of Europa Clipper on that second stage of the Falcon Heavy rocket, and we're looking good so far. The telemetry we're seeing looks like the coast, again, is going well. We expect the spacecraft and the second stage to start to go into a little bit of a roll, and that's intentional, Mick.
Yeah, for thermal protection, to make sure that Europa Clipper stays cool and gets going, and we get that thermal roll that's going on. But everything's looking good, and the initial data we got from Stage 2 performance looked really good and nominal for that second burn. So we're definitely looking forward to Europa Clipper separation here shortly, as we can see this camera view of Europa Clipper on the front of the SpaceX Stage 2 launch vehicle.
Yeah, that's a great shot of the spacecraft going out the forward end. Europa Clipper, the largest spacecraft that NASA has ever built and sent into space on a planetary mission.
There we see the camera view of the MVAC-D that did its job in the shutdown, and the picture of Europa Clipper on the front of the Stage 2. Things continue to look good as we see the altitude of Stage 2 continuing to increase during this coast, and the velocity is ramping down into a steady state. Things continue to look very good, getting ready for separation in roughly 5 minutes.
Now we are having that video signal appear and then disappear. We do know that with the spacecraft doing that thermal roll, that can cause signal fluctuations, right, Mick?
Yeah, absolutely. We're on ground station tracking, and as it slightly moves around, we lose the connection a little bit, but we're getting great data so far as the vehicle continues to perform well.
We really want to be locked in at T plus 1 hour and 2 minutes and 32 seconds. That's the current time that we have for the separation of the Europa Clipper spacecraft, and that is a big moment, and we want to be able to see that because, as we've seen in some past NASA missions, it really looks impressive to see that spacecraft going off into its destination.
Yeah, and this being the largest planetary spacecraft that we've built, it's just going to be very cool to see this separation and go. And we heard Jenny and some of the team talk about it, but it just blows me away, the 30-meter, fairing of the solar rays. Wish we could see that and all, but this mission is just so excited, got so many people behind it, and we are just looking forward, after this successful launch today, we want to get to this major milestone of separation, and things continue to look good for that from that aspect. We've had a lot of people, Daryl, over the years work on this. I'm going to give a special shout out to one of my own, my flight analysis division chief, Mr. Mike Carney. He has been working on a Europa mission for at least 25 years in his career. He started out as a trajectory analyst for a Europa mission way back when at Lewis. And when he came to LSP, he's worked on Europa off and on over the years. So shout out to you, Mike, for the great job, and the rest of the team on Europa Clipper today.
We just passed the 1 hour mark of flight for Europa Clipper and Falcon Heavy. Second stage. As you can see from this trajectory, Mick, it's going away from Earth.
Yeah, this is that interplanetary transfer orbit that we talked about. That first burn got us into that park orbit around Earth. And this second burn on second stage did a great job of getting us on that way as we get ready to separate Europa Clipper to get ready for those flybys, to get those gravity assists to get out there to the Europa moon. Things continuing to look very well on the stage performance as it coasts through, getting ready for separation. Trajectory looks nominal.
And Europa Clipper is going to be deployed in a very high radiation environment. If you watched our broadcast today, you learned a lot about the high radiation, extremely high radiation environment in its destination, but it's also in a high radiation area right now as this deployment is in the Van Allen radiation belts.
Yeah, we talked, one of the things that we had to monitor today during today's launch was solar proton flux. Team had to keep an eye on that for solar flares and things going on to make sure. We heard earlier about the special radiation area where the electronics are and for the spacecraft. And so solar proton flux went very well today, and we got this launch off. Things looking really good. We're about a minute away from payload separation, expected payload separation. Things continue to look good as the stage 2 altitude continues to increase. Velocity has a steady state now for stage 2, and things looking really good for this portion of the mission.
Getting close now. Less than 30 seconds away from separation. There you see the Europa spacecraft. Those massive solar panels that you were talking about all stacked together. This is a big moment for the program, for NASA, APL, and JPL. Let's watch.
Europa Clipper, separation confirmed.
And there you go. NASA's Europa Clipper probe embarking on a long-awaited mission to study Jupiter's icy moon Europa. And what a sight, Mick.
That is absolutely gorgeous, Gerald, to see Europa Clipper on its way. Successful deployment from stage 2. Falcon Heavy performed very well today. Teams behind us are clapping and enjoying. That is a beautiful picture.
Via the video, we can see that Clipper has successfully separated. Please say goodbye to Clipper on its way to Europa.
Now that voice you heard just there is the Europa Clipper flight director, Pranay Mishra. He's with the mission support team.
Okay, all stations, we are waiting for a sign of initial acquisition. Again, Telecom will confirm when we have carrier lock, and DDM will let us know when they see the first packet down.
You can see the second stage and the spacecraft just hit orbital sunrise, fully illuminated by the sun coming over the Earth. And as you just heard the flight director say, they are now going to be monitoring for an acquisition of signal.
Yes, this will be the first time the spacecraft gets information. Looking forward for that.
The hope is that they would get it in the next few seconds. We're now looking at a split screen. On your left, you see Europa Clipper. On your right, this is telemetry coming. Or actually, this is the ground station looking for a spike, looking for a handshake with the spacecraft. And we expect to see that in the form of a blip.
Daryl, as you say, they expect that here in a few seconds, but it can happen in a few seconds or anywhere from 15 minutes from now. So the team is closely monitoring this and looking for that, and we're hoping that we can gain AOS here very shortly.
Yes, there's a broad range of times for which AOS is expected.
Flight GNC. Go. Just wanted to comment from the video that we could see that the sun was on the neg-Y side of the spacecraft. There were very low visible separation rates, and the negative Z-axis was pointed at Earth, so this should be favorable for comp.
Copy, GNC. Thank you.
An acknowledgement from the team that that sunlight could help things out. They're looking to warm up the
Flight phase.
amplifiers.
Go, phase.
Sorry, I missed the session IDs for our SA sessions from GDS. Can you or GDS repeat those for me?
We did not call them out on net yet, but there are 5 session IDs that it will cycle through, so just a note. GDS, could you note those session IDs in your cache report, and then folks can go there and take a look?
So they got 2 radios there that they are warming up. And once they get warm enough, they'll be able to send a signal transmitting down to the deep space network. And that's where JPL, the team that you see there in California, is awaiting to receive that signal. Basically a handshake saying, hey, I'm here, I'm good. The bigger telemetry and the more the data about how it's doing will come down later.
Go.
Did we get confirmation that the alarm file was deployed?
That's affirmative.
Do we have the time at which that deployment was complete?
GDS, do you have a specific time for when that alarm file deployment was complete?
17:05:06.
Systems, you copy that time?
Copy, thank you.
Again, that's Europa Clipper Flight Director Pranay Mishra leading his team. Also, a partner in this mission is the Applied Physics Laboratory, their team on console as well. We're continuing to monitor the search for a signal. And I believe we have it.
Right.
There it is.
Flight, this is... Go, Telecom. Flight, this is Cal. We're seeing the signal on the open loop receiver. Copy, Telecom.
And there you have it. Confirmation of signal from the spacecraft, Europa Clipper. In the room there at the Jet Propulsion Laboratory erupting in applause. These teams have worked a long time. You've got some high fives.
Flight, I got data on SSC. Copy, Telecom.
Flight, this is Telecom. Looks like 12 kilosymbols per second as expected.
Copy, Telecom.
Solid data rate.
We're in lock. Flight, this is Telecom. We're in lock.
Copy, Telecom.
Flight systems.
Go, systems.
We have telemetry. We received good samples, and our displays are lighting up.
Copy, systems. Initial hack is confirmed.
And now they just locked in full telemetry from the spacecraft. Another big milestone.
Flight prop.
Go, prop.
We are vented and primed.
Thank you, prop.
The propulsion system now is ready.
Flight, this is Nav.
Go, Nav.
We see Doppler data.
Copy, Nav.
Break. Flight systems.
Go.
We're reporting status that both branches failed to vent. Can prop please confirm if venting occurred successfully?
I was about to do that. The pressures are good, but we are seeing the valve venting flag. We're taking a look right now.
Copy, prop. Thank you.
Flight GNC.
Go, GNC.
We do see, the telemetry just came in too. We do see that we are already in the mode GNC 3RS tracks on point, and with the Z-axis rate is consistent with the Z-axis roll.
Copy. Thank you, GNC.
That's really good, right? Yeah.
Flight FP.
Go, FP.
So the particular condition about both branch failing venting does not trigger a monitor, and we have no indication anything tripped, so it just moved on to priming.
Copy.
Can hear you, Sammy. Copy.
Is that if both branches fail venting, the behavior moves on to and attempts priming. So if that is successful, we could get into
tracks on point like we're seeing here. Depending on the cause of the both branches failing venting, which we'll look for prop to confirm more details on.
Copy activity. Activity as you see signs of the launch behavior continuing, please call it out.
Yes, if we're flight this activity.
Go ahead.
Being in our tracks on point at this point, we are waiting the hour thermal roll, so we should all be looking for signs of being in the thermal roll right now.
Copy activity.
Yeah, flight GNC, just to confirm it again, we are in the thermal roll right now. And so GNC sees that we have already successfully found the sun, done a slew to sun point, and initiated the Z-axis roll. So good indication that GNC is using the engine successfully.
Copy GNC. Do you have an estimate on the start time of that thermal roll?
We're working that right now. I'll get that back to you.
Thank you. And activity, when you have the telemetry in step 2-8 or can confirm the telemetry in step 2-8, please let me know.
Flight CE.
Go ahead, B.
Is Power seeing anything in the thermal roll? Do we see any change?
Go ahead, Power.
Stand by.
So what you're hearing is that the propulsion system was primed. It didn't get a vent on it, but they have later come to get confirmation that indeed the spacecraft is in a roll, so the propulsion system appears to be working.
Yeah, absolutely. They have all good telemetry and everything going well. The spacecraft team's very happy, and they got into their thermal roll and doing very well. So awesome to see deployment. Awesome to see Europa Clipper on its way for this successful mission. Great job by all the teams on today's launch.
A big congratulations to the teams that have all been working so many years to get to this point. There's still a lot of work to do. Several hours from now, they will begin to cut the thermal knives that will slice open the holding mechanism that allows that solar array to expand, and then that'll bring them power to the spacecraft that'll get them on their way.
Yeah, 30 meters solar. That's just impressive from that aspect. And Daryl, again, a great launch today, great separation. I say to Jenny on the host desk, awesome. Hope you're happy. Hope the JPL's team happy. We at LSP are so proud to provide you with SpaceX a great launch today. Thanks for being with us. And Daryl, as usual, thanks for having me on board for this launch. This was an exciting one.
Well, we appreciate having you, Mick. Thank you for your expertise and your knowledge and insight in this mission. It is always helpful to help us understand what's going on. So thank you very much. And that'll wrap it up for us. So we'll send it now back to the host desk and Megan and Jenny.
Yeah, thank you so much, Daryl and Mick. It was really cool to have you guys in there walking us through all of those milestones. And yes, I can confirm for you, Mick, that there were some happy tears next to me. more tears. So to recap, for those just joining us, the Europa Clipper spacecraft has separated from the Falcon Heavy second stage. It's on its own in space, but the team has confirmed a signal from the spacecraft and is now getting all the data that we were expecting from the spacecraft. How are you feeling in this moment? I know we just said happy tears.
Happy tears. I know seeing the separation and the spacecraft moving away from the second stage is just, that's the last time that, human eyes will see the spacecraft, right? From now on, it's on its own. And so that's incredible. And getting AOS and then the full telemetry right afterwards, it's, we test these things, but it's amazing to see it happen and confirm. There's a little bit of relief in there.
Yeah. We're going to hear from JPL in just a little bit about what full telemetry is, but explain why that is such a big deal.
Yeah. So it basically allows all of our different subsystem experts to weigh in and say, okay, I'm seeing, my system looks good. My system looks good. I'm checking this. That looks, that's in the range we expect it to be. So it allows us to really understand the full kind of health of the spacecraft.
And so that's why you were cheering.
Yes.
She was in the room. Yes. All of us in the room were cheering. Again, a huge moment for the Europa Clipper team. And I know so many of you guys out there as part of the team, part of Jenny's team, really share in the relief and excitement. So let's get some more reaction from Mission Control at NASA's JPL in California. Raquel, all the cheering that we saw in that room was super cool to see.
Yeah, Megan, and the cheering hasn't stopped. We just heard some moments ago, and the team is still celebrating. And right now we are joined by Tim Larson, Deputy Project Manager for Europa Clipper. Now, Tim, there's been a tremendous amount of work that went into this moment. Tell me how you and your team are doing.
This is so exciting. This is a culmination of the work of thousands of people representing millions of work hours over the years to design this mission, to design the spacecraft, build it, to test the entire system to make sure this system is now able to do everything it needs to do on the way to Jupiter and once we get there in our orbits around Europa. This is every person here and has contributed to this have all contributed to making history today.
And we have acquisition of signal and telemetry. Can you tell us about that data that you've received?
Yes, that's the data that tells us the spacecraft, the state of the spacecraft. It tells us what equipment is on and off, the temperatures, voltages, currents, software messages that tell us what's going on. So all of that informs the team in the MSA, and they can now start evaluating the state of health of the spacecraft and its readiness to keep going.
And we're celebrating now, but there is still a lot of work ahead. Can you walk us through what the next few weeks look like for Europa Clipper?
Yeah, this is going to be a busy time for the team because now that the spacecraft is flying on its own, we'll go through a series of activities where we check out every bit of equipment on the spacecraft, make sure that every subsystem is working as it's supposed to, and then we'll start a series of activities checking out the instruments on the spacecraft. And we have a couple of key deployments that come up right after that, deploying the boom for the magnetometers and deploying the antennas for the radar instruments. So it's going to be a busy few weeks.
Exciting times ahead. Tim, thank you so much for joining us, and congratulations to you and your team.
Thank you. This is so exciting for the entire team.
And that'll do it here at JPL. Megan, back to you.
All right, I'm back here at the Space Coast. We are now joined by Dr. Denton Gibson with NASA's Launch Services Program. Today, he was on console supporting the launch. Another successful mission for you guys.
Yes, it was, and an exciting one. It was a beautiful day to launch a rocket to Europa.
Absolutely.
I mean, we couldn't ask for better weather, so that was amazing. But first of all, I just want to say thank you to the amazing team that we have, the combined NASA, SpaceX, LSP JPL team. It did an amazing job. And this team never stops amazing me. Yeah. I mean, just a couple of days after we had a extremely major hurricane hit, with a lot of teams still without power, we were able to get through this countdown and have this amazing launch. And we couldn't ask for a better team that was working this. And I could just say, and of course, our partners at the Space Force also supported us through this launch. But it was just amazing that we got through this.
Yeah.
Well, and I'll just say, as a member of the Europa Clipper team, we are very grateful for the ride to space. So thank you so much.
Yes. So it was awesome.
Yeah, and specifically, I mean, speaking from the team, the fact that, again, we were talking about this earlier, that NASA and SpaceX were able to bring this together to bring us to launch today. Talk a little bit about that with Denton.
Mm-hmm. Yeah, especially right on the heels of a hurricane. It seems like this was a monumental effort to get to this point.
Yeah, absolutely. Yeah. And, even though many members of our team are still without power.
That's right.
We all work together as a team. We came together to turn the things around quickly. The KSC was able to open and get our teams in to start looking at the spacecraft launch vehicle, working through anything, impacts from the hurricane. Thank God there wasn't many significant impacts, so we were able to work through that. We were able to get the team together to work things and able to get to this point. Mm-hmm. So it was a huge monumental task. But this team really came together and got it done.
Mm-hmm. Yeah. Jenny, do you have any questions for Denton? Again, I think you're kind of speechless right now.
I know. I mean, what does it mean for LSP to be part of Europa Clipper's journey?
I mean, the mission itself is amazing.
Yeah.
And to be the team that helped enable the spacecraft to get where it needs to go, to get the science that everybody's looking forward to getting. Right? I mean, I couldn't tell you how excited I am to really get and hear some of the science of the discovery that's going to come from this mission.
Yeah.
So it always means a lot to LSP to be entrusted with such a monumental mission and to get it where it needs to go successfully. So that's always, significant to have us be a part of that. So
incredibly beautiful launch.
Yeah, you guys enable so much science that could really change our outlook on our planet, on our universe. So thank you for that. And because as a little thank you to you, I know you guys love our launch highlights. So why don't we take a look at another launch replay from today's Europa Clipper launch.
And here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Liftoff of Falcon Heavy with Europa Clipper, unveiling the mysteries of an enormous ocean lurking beneath the icy crust of Jupiter's moon, Europa.
engine chamber pressures are nominal.
See that the chamber pressures are nominal as we hear. All 27 Merlin engines look great.
Rocket beginning to roll. Putting down 5.1 million pounds of thrust. Coming up, they're going to back off those engines just a bit.
So we get ready to head into max
Power
Q.
and telemetry nominal.
We hear that power and telemetry on the vehicle are good there. Everything's looking really
Falcon
well.
Heavy is supersonic.
They have reduced power in the center core to get through max Q, maximum dynamic pressure on the launch vehicle as we approach that. The two side boosters at full throttle.
I feel like Jenny couldn't really watch that video because she was going to start breaking down again.
I'll watch it later.
Yeah, it was really cool to see that again, those highlights from today. It really just brought me goosebumps again to be thinking about the science that this launch is enabling. So that's going to wrap it for us here at Kennedy Space Center for this live launch coverage of NASA's Europa Clipper mission. A huge congratulations to everyone involved and a big thank you to everyone who participated in our broadcast, especially Jenny Kampmeyer. Thank you so much.
It's been so fun to be here, and I just love this is the start of our journey of exploration, scientific discovery, everything we're going to learn from Europa. It's just amazing.
And again, this is huge for astrobiologists around the world, but really all scientific disciplines can really gain something from this.
Absolutely, and it's going to change our understanding of kind of our place in the universe. If this is a world that could support life, what does that say about other solar systems that may also have worlds, like Europa?
So you got to wait 5.5 years, though.
I know.
How do you feel about that?
We got to be patient, but it's going to be worth the wait. I think we'll all be sitting on our hands anxiously waiting to get to Europa, but it's going to be worth it.
And obviously there is work to be done while it's coasting there. One other thing that I wanted to bring up for before we let you all go is, Jenny, talk to us a little bit about your trajectory, how you got here to NASA, because I think that's an inspiring way to maybe end this broadcast.
Yeah, people always ask, how can I work for NASA? How do I get to do what you're doing? There's a lot of different paths. My path was a little bit non-traditional. I started my career as an adult as a musician. I was a classical musician and orchestra librarian for a bunch of years. I went back to school for engineering, and now I'm here at NASA. And it was actually watching a launch that kind of kicked me down that path.
Mm-hmm.
So if you're out there and you're thinking, I want to work for NASA one day, just go down the path that you want to go down, and you can get there eventually.
Yeah, and we're so lucky to have you. Thank you so much. And if you want to continue to follow along with this mission, just scan the QR code on the bottom of your screen. I promise it's the last one. This one will take you to europa.nasa.gov. Together, we will discover the mysteries of both Europa and our home planet. Have a great day, and go Europa Clipper.
T-minus 10.
I've never been more excited about the possibility of discovery.
We are now at the point where we can bring together lots of different types of people.
You talk about grit and determination and resilience.
These are areas that humans aren't designed to go to.
We put together this amazing adventure and mission.
So when I turn it on,
whoa!
Decisions we might make could influence other things.
And it's everything. I hope that we can do something to turn us around.
There are many questions raised by the mission that we still need to answer.
The story is never complete.
Europa is widely considered the most likely place in our solar system beyond Earth to have life right now.
It's a moon, an icy world orbiting Jupiter.
Beneath its icy surface, a global ocean of water. Everywhere on Earth that there's water, there's life. So we want to understand, could Europa be a place where life might exist today?
3, 2, 1, lift off.
Europa Clipper is the first mission dedicated to exploring Europa.
This is the largest interplanetary spacecraft NASA has ever built and launched.
We have the right team, the right technologies to leverage to go to Europa now and unlock those mysteries that are just waiting for us.
The pictures we're going to get from Europa Clipper are going to blow our minds.
How could you not be excited about something as monumental as this?